So now it's my great pleasure to welcome the amazing Dr. Jeffrey Schwartz, a research psychiatrist at the University of California and one of the world's leading experts in neuroplasticity, particularly as it relates to obsessive-compulsive disorder. It was his work that demonstrated how thoughts can actually change brain chemistry, and his work has actually informed a lot of mine. And he's the author of several groundbreaking books. He's also a Hollywood advisor on characters with mental disorders, such as Howard Hughes, portrayed by Leonardo DiCaprio in the movie The Aviator, and you can see some of these interviews on his website. This morning, Dr. Schwartz will speak about the neuroscience of habits and how we can reframe our thinking to overcome them. Please give him a warm welcome.
Thank you, Helena. I really appreciated that. And thank you very much. And thank you to Beth and Tony for inviting me. And it's always great to be in Sydney. And every time I come here, I love the place more. So hopefully you'll be seeing more of me as time goes by. The subject matter for today is a very significant one and a pretty serious one, too. The neuroscience of habit. For many years, I have been representing the position, you are not your brain. Not been a mainstream position in neuroscience. At the margin, that might be changing a little bit. I hope it is. But this subject matter for today, the neuroscience of habit, is really where the rubber meets the road. Because those who think you are your brain, which really does represent the majority of people who are in high bureaucratic positions in the field of neuroscience, habit is one of the strongest things they have to fall back on, because if there's anything that really does say you are your brain, it's habit. So what I'm going to try to do today is show you just how powerful a thing habit is in the brain, and it's very, very powerful, as hopefully you're going to get a good appreciation from in this presentation, but also the fact that our old friend mindfulness is still the way to get beyond the neuroscience of habit, so that in the end, hopefully we'll all still be able to be very confident of the fact that in the final analysis, you are not your brain. But the neuroscience of habit is so powerful that it takes work and effort to accomplish that. So this picture, which I've been using for many years, shows diagrammatically, it's obviously a very famous drawing by Escher, the great Dutch artist, that I just mocked up to be the mind and the brain. Well, for many years, I've been defining the mind for scientific purposes as the choices and decisions we make about the information that our brain sends us. So there's no question that we're getting a constant stream, a constant, steady stream that doesn't even really stop when we're asleep, of information from the brain. So there's no controversy that the brain is extremely powerful. What's left is the choices and decisions that you still can make about the information that your brain is sending you. The reason why the neuroscience of habit is such a powerful and important subject is because the nature of habit and the way it's wired into the brain basically detaches it in very significant ways from choices and decisions. So it takes an extra effort to bring the mind into habit, and the brain takes over the mind very significantly in the neuroscience of habit. So habit is, if you can learn how to beat habit, you really, really, really can say, I have a powerful mind, because the choices and decisions that I'm making are changing my brain and changing how I respond to information. But the bottom line of the power of the brain in habit is that it really does hide itself from choices and decisions. Habit really does in some ways operate on something that's very close, but very importantly, not fully automatic, but very close to automatic. And that very automaticity really makes it hard for choices and decisions to penetrate into the process. So the neuroscience of habit is a very important subject. William James, one of the fathers of modern psychology, and one of the greatest, if not the greatest, of American philosophers, wrote in a book called Talks to Teachers the following very profound statement about habits. He said, "We are mere bundles of habits, imitators and copiers of our past selves. Habits are the stuff of which behavior consists." What he was taking into account here is just how much automaticity there is in how we act. We're largely run on automatic pilot. Where the mind comes in, and William James, of all people, was extremely aware that the mind can enter into this process. Because, in fact, even in this essay, which was Talks to Teachers about how to teach their students about what? How to teach their students how to form good habits. That's really the point. William James, for me, his most important line was one that stated volitional effort, willful effort, the effort that we make by choice, is the effort of attention. So here is William James simultaneously saying that we're mere bundles of habits, imitators and copiers of our past selves, and yet there still remains this issue of how do we pay attention? And paying attention with mindfulness takes effort, and paying attention in ways that make us aware of whether a habit is a good one or a bad one takes effort. So William James is a very good model for the fact that the neuroscience of habit is very powerful, that habit is an extremely powerful thing that's more than capable of making us act basically like robots, very sophisticated robots, but that with effort we can pay attention and learn how to enter into and change those habits. But how? That is the big question. I spent a lot of time in earlier parts of my career studying obsessive-compulsive disorder. And I have a little model of the brain here. I'm going to enter a part of this talk now where there's going to be a fair amount of neuroscience. And I'm going to try very, very, very hard to make this neuroscience understandable. So please bear with me. And I'm going to be presenting sophisticated experiments, all of which were done in the last 3 years. So this is new neuroscience, and hopefully I'm going to be able to convey to you some very powerful and very interesting information. But this is anything but new. This is a study that was done almost 30 years ago now on obsessive-compulsive disorder, and this top slide here shows that people with obsessive-compulsive disorder have an overactive orbital frontal cortex. And in this brain model, you can see that the orbital frontal cortex is the bottom of the front of the brain that sits right over the eye sockets. The big part of the brain that we're going to be hearing a lot about today is called the striatum. The striatum, which in human beings is made up of two structures called the caudate and the putamen, but just know it as the striatum because that's the name that it goes by in humans as well as in all other mammals. And also actually in rodents and birds, and reptiles and birds. And it's a very, very powerful part of the brain that also gets called the habit center. And it sits deep in the core of the brain. This section that you're looking at is basically sliced this way. And so when we open up the brain and look inside, we're looking right through the caudate nucleus, but as I should say, right through the striatum. Now here's another picture, because I want you to see just how deeply embedded in the core of the brain this structure is. This is actually a picture that appeared the year before last in an article in Discover magazine about my work called In Defense of Free Will, and it's right on the homepage of my website, jeffreymschwartz.com. And here we see a very nice artist's rendering, again, of a half of the brain, and you can see in 3 dimensions how the striatum is right in the core of the brain. It sits really right. There's one on each side, but they sit right in the core of the brain. So there's one on this side and one on this side. And here you see that area that was in red, that deep red area in the other picture I just showed you. This is the orbital frontal cortex. The orbital frontal cortex is a part of the brain, among many other things, that reminds us or gives us a feeling that something is wrong. It's also involved, as we're going to hear more about in a few minutes, in making decisions about value. It's become a very key area in the study of neuroeconomics, how the brain interacts with the field of economics. And what we're looking at today is the relationship between this whole outer structure here called the cortex and how that cortex interacts with the striatum. And basically what happens in OCD in ways that are pathological and in habits in ways that can be very normal and extremely adaptive is that the striatum, this part right here, acts like an automatic transmission in an automobile. It's pretty analogous to that. It actually takes over the gearing of the cortex, which is the advanced outer surface of the brain, and runs it automatically. When the circuits that it's running automatically are adaptive, we call those good habits. And that's what we want, good habits. But when the circuits that it's running are not so good, we call it bad habits, or even worse, because this area of the brain is very involved in obsessive-compulsive disorder, it's very involved in drug addiction, it's very involved in a lot of problematic human states where people's behaviors get out of their control. And the reason why their behaviors get out of their control is because they're running on automatic. Now, this is actually a reasonably good cross-section through the striatum. And what it shows is that, even though it's obviously schematic, is that the striatum has 3 main sections in it. The habit section, the section that is wiring goal-seeking behavior circuitry, and reward circuitry. The reward circuitry is largely run by a neurotransmitter that has become very famous in the last quarter century, dopamine. Dopamine, I think many people now know, is related to the feelings of pleasure, the feelings of reward. It's also the neurotransmitter that largely mediates the drugs of abuse, like cocaine, because when cocaine strengthens dopamine signaling, it gives feelings of pleasure, and as we all know, that can rapidly lead to very bad habits. So it's worth knowing right away that reward can be a very two-edged sword. It can be good, but it also can be bad. And one of the reasons why it can be bad is because it can wire in. It's right next to and has, as we're going to see in more detail in a moment, a very profound effect with the habit circuitry that's out of our conscious control. So feelings of pleasure and feelings of reward are very powerful, but they're also very dangerous potentially, because if they're not hooked in to behaviors that are adaptive and good, that they can cause a lot of problems. And also what happens, and another core part of what habits are, is that as the habit center and this habit part of the striatum gets more and more and more wired in, it becomes less and less and less connected to goal seeking. So one of the reasons why habits are so powerful is because they actually detach themselves from decision making. They detach themselves from goal seeking. And so habits, this is what we mean when we say habits are largely automatic. What's really been learned in the last 20 years, with major advances in the last 5 years that I'm going to tell you about right now, is how does that happen? The actual physical mechanisms of how that happens have been very significantly well understood. And the laboratory of Anne Graybiel at Massachusetts Institute of Technology, MIT, has been a central place where that has happened. Now, I've been very honored and fortunate to be a friend of Anne Graybiel's for 20 years because very early on we both realized that the striatum, which she is essentially the world's leading authority on, is involved in obsessive-compulsive disorder. And in fact, I got cleared from her over 20 years ago, calling the striatum the habit center for presenting obsessive-compulsive disorder. Now I'm going to show you some work that she has had done in her laboratory in the last 3 years, very recent work, most of which was done by Kyle Smith, who is now at Dartmouth College, but was a postdoctoral fellow at MIT in Anne Graybiel's lab. And I'm going to now show you some experiments that were done by Kyle Smith as a postdoctoral fellow working in Anne Graybiel's lab. Anne Graybiel, for many years now, has defined what is a habit as a chunk of actions. What do we mean by that? We mean that a habit is a sequence of actions that is treated by the brain as a single unit of behavior. A sequence of actions treated by the brain as a single unit of actions. And it's the striatum that makes that happen. And the reason why these brackets here are in red, you're going to see in real scientific data in one moment. Anne Graybiel coined the term task bracketing for what the striatum does. It actually, as the habit forms, the striatum, as you're going to see in one moment, brackets the neural circuitry of the behavior that then is treated by the brain as a single unit of action. Let me give you a very concrete example of that from my own life. 30 years ago or so, just about 30, I stopped a 1 to 2 pack a day cigarette smoking habit. So, just to be a little humorous here, yes, I was smoking cigarettes when I was in 7th and 8th grade. No. I was a little older than that. But I was, as a college student and even into medical school, I had a significant cigarette smoking habit. So I know from very personal experience that the extremely complex action of taking a cigarette out of a pack, putting it in your mouth, taking it out either a pack of matches or a lighter, lighting it, holding a fire about 2 inches from your nose, lighting the cigarette, putting it away, and taking that puff and breathing it out, all of that can happen without you even knowing it happened. That is a chunk of actions. The whole act of taking out the pack, taking out the cigarette, taking out the lighter, or taking out the matches, lighting the match, and then the key, the thing that makes you realize just how powerful this is that you're now holding a flame about this far from your nose, and you don't even know it. You're not even aware of it. It's all happening automatically. You smoke the cigarette, you put everything away, and if somebody then asks the chronic smoker, of which thankfully there are a lot less than there used to be, but there are still plenty, are you aware that you just lit a cigarette, sir? No, I'm not. Because it's all been done by the striatum. It's a chunk of actions. That entire process of many complex, intricate actions, including holding a fire right in front of your nose, is done without being aware of it at all, automatically. Habits are powerful. So how does that happen? Okay. This is a key experiment that was done, a set of experiments, a actually large set of experiments that were done over several years by Kyle Smith working under the direction of Anne Graybiel in the Graybiel lab at MIT. And this is work that was done in rats, but as you're going to see, it's work that has a lot of relevance to humans. Basically what this is called a T-maze. And what happens is the rat runs down the maze and then a tone sounds. And the tone tells the rat either turn left to get chocolate milk or turn right to get sugar water. And rats like both chocolate milk and sugar water. And so over several hundred trials, the rat actually learns to recognize the sound, and the sound that turns left, it turns left, and when it does turn left, and it gets the chocolate milk. And another sound, a distinctly different sound, it learns to turn right and gets the sugar water. All of that is called goal-seeking behavior. It's not a habit. That's all goal-seeking behavior. And I'm going to come back and forth between these two slides a few times now to show you how this works in the brain. This area down here in the midbrain is where the dopamine lies. And this area up here is the frontal cortex. So frontal cortex, and then down here in the midbrain, dopamine. What's the relationship? Because in this process of learning a new behavioral habit, we get the frontal cortex strongly interacting with dopamine in the striatum. What happens is, when the rat follows the instruction correctly, turns left on the signal that tells it to turn left, drinks the chocolate milk, dopamine comes out, and the rat gets this feeling of, we assume the rat's going, this is great, chocolate milk. And similarly, turning the other way to get the sugar water when it does it on the proper signal. This is all the goal-seeking part of learning. This is not habit yet. This is learning. It involves the frontal cortex, and it involves reward signals from dopamine, but they are interacting in the striatum, in that special zone of the striatum that's involved in goal-directed behavior. Okay, that takes a couple of hundred trials. Now the rat knows how to do that. Then, Kyle Smith overtrains the rats, and this overtraining part is very important. Now he runs the rats on this hundreds and hundreds of times. Hundreds and hundreds of times. And as the rat is running that task again and again and again, habits develop. And what happens, and this really shows you how powerful habits are. To show that a habit is formed, this is how they do it scientifically. They actually associate one of the rewards with a small dose of a drug that causes nausea. Now the rat is going to be associating what was a reward with a feeling of nausea. The thing that shows just how powerful habits are is that when the tone sounds, the rat will keep running to the thing that now causes nausea. Habits are powerful. Once they get embedded after hundreds and hundreds of trials, notice the goal-seeking and the reward don't even matter anymore. We see this in eating all the time. We see this in cigarette smoking. We see this in so many behaviors. You know, you eat, candy dish, take the candy, put it in your mouth, eat. Cigarette, there's so many examples. We've heard many of them in this meeting. The thing to remember, the key here, is that the habit no longer depends on the reward. The habit has a life of its own. These animals will run to the side of the maze that causes them now to become nauseous just because they've done it hundreds and hundreds and hundreds of times, and it's now wired into their habit center. What has happened in the brain there is that, and by the way, this picture is from, you can easily get this picture on the internet. This picture, and the last one too, is from an article that was published in 2014 by Kyle Smith and Ann Graybiel in Scientific American. It's very easy to get. You can purchase it from Scientific American or even look for it on the internet and you can find it. But it's a Scientific American picture. So you can get this diagram easily. It's from an article in Scientific American. And what's happened when the rat now is no longer running in a goal-directed way, now the rat is running in a habitual way. And when it's habit, it moves from the front of the brain, the so-called executive brain, the decision-making part of the brain, to a much more automatic part of the brain that's about right over here called the sensory motor cortex. So now the behavior is being run just by body circuits. It's no longer really being run by decision-making circuits. So now the striatum is actually running the behavior connected to just physical movement, basically detached from reward. This is where the task bracketing comes in. Because if we look at how this rainbow array here shows the activity of nerve cells firing in the striatum. And what you can see is that as the rat is just exploring and learning the behavior, all the cells in the striatum are pretty active, very much including the goal-directed circuits in the striatum. As the habit starts to form, you can see the task bracketing starts to occur, and you see very intense firing of the striatum nerve cells as the rat makes the decision which way to turn and gets right by the reward. This area now, in blue, is much quieter. However, the goal-directed area of the striatum is actually still active here. So as a habit is forming, the goal-directed part is still active, and the habit part of the striatum is getting quieter and quieter. And when the habit gets fully imprinted, where the animal will run, or we as animals will literally run to things that we basically know aren't good for us anymore, the habit has become imprinted into a chunk of actions. And here you see the bracketing. Because what the striatum does now is basically set apart the behavior beginning and end. You see very high firing. And what's in between is this complex brain circuitry that is now being treated and run like an automatic transmission by an automatic habit center that basically is making the brain run on automatic. There's one more very important part of this. There's an area of the cortex, this advanced area of the brain, that sits right here near the bottom in the middle of the brain. It's called ventral towards the bottom, medial in the middle, prefrontal cortex. That area of the brain in human beings is clearly now related, through work done just in the last decade, to things that are viewed as relevant to ourselves and valuable to ourselves. And in an amazing set of experiments that was done in this Kyle Smith, Ann Graybiel set of studies, they showed with advanced technological intervention, which is now being widely used in neuroscience research, that you can inactivate very small, discrete areas of the brain. And what they show is that when you inactivate this area, it immediately breaks the habit. So now the rat is running to the thing that makes it nauseous, because it's just a habit. But all you do is just once or twice inactivate this area of the cortex, and the habit immediately breaks. Immediately breaks. It's shocking, actually. Here is a habit immediately being broken just by inactivating one little area of the brain. But it gets even more amazing than that. Because the thing that really is profound and a little bit scary, actually, is to realize that habits don't just come and go. When habits form, they get deeply embedded, and they're still there. And the thing that shows that is that a couple of days later, the habit now has still been broken. The rat is no longer running to the thing that makes it nauseous. In fact, it develops a new habit. Now, no matter what tone sounds here, the rat always runs to the reward, to the thing that it still likes, the thing that is not associated with being nauseous. So now the tone doesn't matter anymore, the habit is broken, and no matter what tone sounds, the rat runs to the reward. It's learned to a new habit. No matter what tone sounds, run to the reward. It's not running to the thing that makes it nauseous anymore. But 6 days later, or a week or so later, if this little area of the brain gets inactivated again, immediately the habit comes back. Immediately, the rat starts running again to the thing that makes it nauseous, just by once or twice inactivating this area of the brain. The habit was always still there, and it can come back immediately just by having that area of the brain be inactivated once or twice. Now, how's this relevant to humans? It's actually very relevant to humans. Because just think of the cigarette smoking example. Think of the person who has an alcohol problem example. Think of the person who has a chocolate eating problem example, and on and on and on. They work, they train, they do behavioral modification, they quote-unquote break the habit. Now they're not smoking too much, they're not drinking too much, they're not eating too much of bad foods. But what happens? They get under stress, they get with friends who are still into those things, they get into an environment, they have, how many does it take? We all know. 1 cigarette. How many cigarettes does it take for the habit to come back? That's about right. 1 cigarette and boom, it comes back. You can see that this study in rats is showing something that's absolutely the same in human beings. The habit's still there the whole time. 1 or 2 little miscues and boom, the habit comes back full blast. Habits are powerful. We think we have them beat. They're still there, ready to start bothering us again. It's powerful stuff. I'm going to now finish. I have 15 minutes to go. Hopefully, the neuroscience stuff is almost done, so hopefully you all look basically awake. Thanks for that. The ones who are sleeping are good at hiding it, and you probably showed that when you were in school, and probably learned that in school. But I know that you all got good conduct grades in school, everybody in this audience. So now I'm going to show you another 2 sets of experiments that are a little easier to understand, I think. This is one that's really fast. This is actually just from 2 years ago. This is a paper that's been cited many, many times, even though it was only published in 2013. And what does it show? It shows that the subjective value, what does that mean? Subjective value is summarized by that simple term, it's valuable to me and it's relevant to me. Things that are valuable to me and relevant to me, well, look at that. They activate that same area, This is a very important area. That same area, and what else? That's the dopamine area. That area is this. These are 2 completely different studies. And actually, honestly, these 2 lines of research have never quite been tied together yet. So it's new research. And I think it's rather exciting because we're now tying together the subjective value part of the brain with the habit part of the brain. And we're showing that this part of the brain is very, very powerful because in subjective value experiments, many subjective value experiments, that's what the word meta-analysis means. In this paper by Bartra, he reviewed many studies looking at what happens in the brain when we see something that's valuable to us and relevant to us. And what happens is those same 2 areas I've been talking about get activated. This area right here, the so-called ventromedial prefrontal cortex, and the dopamine area. That's what you're seeing right there. Now let's get into an experiment that really brings home the mind and its potential part. This is the part that's really relevant to this meeting. What can we do about this? Well, there's a study that was published this very year. This paper was published in the Proceedings of the National Academy of Science in 2015, this year. First authored by Emily Falk. And what she shows is that self-affirmation alters the brain's response to health messages and then leads to behavior change. And this is how they did it. Self-affirmation. We've heard a lot about that in this meeting, and that's very relevant to this organization as a whole. Self-affirmation is very, very powerful. And what this experiment shows is there's been a fair number of experiments in the last 10 years showing that if you show health messages to people who live too sedentary a life, they don't exercise enough, it's always sitting at work, driving back and forth to work, and they don't get enough exercise. If you show health messages to those people to try to say you need to exercise more because if you don't exercise more, you're going to get diabetes. If you don't exercise more, you're going to have high blood pressure, et cetera, et cetera, et cetera. People tend to go like, later for that, Jack. I don't want to hear these bad messages. And so it's well known that health messages don't change people's behavior very much. So the science of this has been trying to say, well, what can we do to improve that? And the thing that's been discovered that improves it is self-affirmation, and a very specific kind of self-affirmation. The kind of self-affirmation where you ask people to reflect on their core values, And so the way this experiment was done is they put a now fairly well understood experimental method into people who are sitting in or lying in brain scanners, and so we can see what happens to their brain as they do self-affirmation. And self-affirmation, you basically ask people what are the kinds of core values that are the most important to you. And the general categories are things like creativity, family and friends, faith and religion, sometimes money, spontaneity, even politics. I do like to say that, at least now in America, the people who list politics as their core value for self-affirmation, they might not belong in a study for normal people. But, so maybe we should go down to like one less core value for normal people. But certainly I would say creativity, spontaneity, humor, family and friends, and I myself will put in my vote for faith, because I think faith is a great core value. And when you ask people, and here it is, whatever your chief core value is, they ask people to think about your chief core value, and then they play them health messages. It's already been discovered that when people are reflecting on their chief core value, the thing that gives them a sense of, my life is valuable. My life, other people care about me. I'm a part of my community. My faith is very important to me. I'm close with other people who share my faith. And then have them listen to health messages. They respond better to the health messages. They don't just ignore them. What this study shows is that those self-affirmations done prior to listening to health messages, look at the brain area that gets activated. These are people who are changing their habit. The ventromedial, down, bottom of the brain, middle, prefrontal cortex, the ventromedial, prefrontal cortex gets activated by self-affirmation messages, and look what happens. Their activity increases, because this says sedentary. They get less sedentary. The self-affirmation activates the part of their brain that says, this is valuable to me. This is relevant to me. Self-affirmation helps them realize this is important for me. And they actually listen to the health message, and over the next month, they actually exercised more and were less sedentary. It's powerful stuff. Now we're starting to see, how do you change a habit? You got to change your values. But how do you change your values? By thinking about the things that are really and truly and genuinely important for you. Healthy self-affirmation activates the part of the brain that allows us to change habits. That's the big take-home message of this talk. And so let's now just spend the last few minutes here on our old friend mindfulness, because mindfulness really helps us do that. And what is mindfulness? Okay, I'll just read the list, and there's going to be a workshop later with a lot more detail. It's an activity, it's a state of mind, it's an awareness, it's a focus, it's an acceptance. All true. But the common denominator of all of those things, and what the activity of mindfulness is having an outer perspective on inner experience. What we sometimes call, I use this term from Adam Smith, the great Scottish philosopher and father of modern economics, founder, I suppose you should say nowadays, founder of modern economics, the impartial spectator. The impartial spectator. The part of us, the part of our minds that can look with a clear-minded, fair-minded perspective on our inner experience. That is mindfulness. I use in my work in You Are Not Your Brain, I use the term wise advocate. Other words that can describe the kinds of plain English words that are very consistent with using mindfulness: helper, inner helper, comforter, advocate, counselor, encourager, strengthener, friend. Every person has access inside of them to helper, comforter, advocate, counselor, encourager, strengthener, friend, impartial spectator. All of these are words that I think are clearer now than even the word mindfulness itself, which is, let's be a little candid, has become a little overpopularized and has lost its meaning in that overpopularization process. And the components of mindfulness are direct knowing, deep experiential awareness, being knowledgeable about what's happening in the moment, approaching your experiences and observations outside in, observation, rather than just cloudy, fuzzy thoughts and concepts. But I say consult your wise advocate. Consult your inner helper, comforter, advocate, counselor, encourager, strengthener, friend. Get that impartial spectator, supportive perspective. Now, there's one other really important thing that I want to bring home in this talk about mindfulness. The question comes up: is mindfulness judgmental or non-judgmental? And the answer is yes. And I'm going to show you why right now. This might be the most important thing in this whole talk, because this is a message that's easy to understand but hasn't been well enough understood. Mindfulness is certainly non-judgmental in the sense that you have to examine the thoughts, urges, impulses, preferences, and so on that come in. You can't edit them. You have to be honest with yourself. It's about transparency. It's about seeing what's actually going on. So you can't have an inner editor. I actually have a video, a 4-minute video on this right on the homepage of my website, jeffreymschwartz.com, just describing this process. You have to pay attention to what's really there. That is genuinely non-judgmental. You can't be editing. You can't be going, no, I shouldn't be thinking that. No, that couldn't be me who's thinking that. It's you who's thinking that. Own it. It's yours. But that doesn't mean you should keep it, and that doesn't mean it's great because it's yours. And that's part of the biggest part of this message. Just because it's yours don't mean it's great. I'm really assertive about that. My New York accent really comes out when I say that. And that's where the quote-unquote judgmental part comes, because it's not judgmental in scare quotes. It's not like, don't be judgmental. It's have discernment. It's use assessment. Don't think it's great just because it's yours. Let's be honest. All of us have a lot of things going on inside of us that aren't so good. We need to do something about it. Change those habits. True self-affirmations. Consulting the inner wise advocate, helper, comforter, advocate, encourager, strengthener. Use discernment. Use assessment. Judgmental in the good sense. Using good judgment. Why has that term gone out of style? Let's bring back good judgment. Let's hear it for good judgment. Hooray! So, you need to use both. And with mindfulness, going back to texts that are 2,000 years old, describing oral teachings that are 2,500 years old. Yes, started by Gautama, who was called the Buddha, which means awakened one, but equally so by Jesus, who was called the Christ. We can use mindfulness to both bridge and strengthen the connection between non-judgmental observation and using assessment and discernment. And that kind of self-affirmation, use of wise advocate, strengthens our capacity to change habits, become aware of what those habits are. And so we want to bridge that gap. You don't edit the content, but you use judgment and discernment and ask, is this a helpful thought? Is this a helpful behavior? Become aware of behaviors that you're otherwise unaware of because they become so automatic. When you see what they are, you can do things that will help you change them by consulting your inner wise advocate. So, deceptive brain messages, now I'm going to finish up really fast. Deceptive brain messages are bad messages that come into our brain from the habit center. There's a cycle of deceptive brain messages. This is all from my book, You Are Not Your Brain, that lead to habitual unhealthy responses that happen again and again and again and again. Hopefully it's clearer why that's true now. Mindfulness practice, I like this picture because it shows all the extraneous stuff that is constantly coming through our minds. That's what you learn when you practice mindfulness. There's a lot of nonsense that's running through everybody's mind. And that's why you have to have a lot of assessment and discernment about what those things are so that they don't hold your attention. That's volitional effort is effort of attention. Mindfulness is the effort to not have your attention be determined by all these things that are running around in your mind. So I'm just going to skip right away. I didn't have time for this. I'm going to say very good work done by Wendy Hassenkamp about what happens in your brain when you do breath awareness. We'll have to do it another time. You use your wise advocate. I told you about that. The mind is passive. The brain, I'm sorry, I said that backward. The brain is passive. The mind is active. The mind is the choices and decisions that you make about the things that your brain puts in, your conscious awareness, and you have to use the brain and the mind together as a team by using this method that I call the 4-step method: relabel, reframe, refocus, revalue. That is the core of my book. But the term wise advocate is really, I think, the most important term now. So the brain puts out the call, the mind decides whether to listen. That's the big message. The meta model will have to wait for the workshop. We're trying to get to a true self, which we will by following these kinds of principles. And I guess I'm just going to skip to the end and say we have a webinar series. Josie Thompson and I are doing a workshop this afternoon on all of this and how to put it into practice. And we also have a webinar series that you can sign up for and watch. And hopefully what you've heard today is of interest, and you'll follow up on how to practically apply the principles I've described for you today in changing the way we actually live our life so that we no longer are run by habits. We're not robots. We're intelligent, mindful people making choices and decisions about what to do with our brain's information. Thank you very much for your attention.